This lesson is on applying special right triangles. A diagonal of a square divides it into two congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So another name for an isosceles right triangle is a 45-45-90 triangle. A 45-45-90 triangle is one type of special right triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of 45-45-90 triangles. In a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is the length of a leg times the square root of 2. So AC and BC are congruent, and AB is equal to AC or BC times radical 2. Here we have a side length of 8 for a leg, so we want to find the value of x. So the hypotenuse is the leg times radical 2, so our answer for x would be 8 radical 2 because we take the leg and multiply it by radical 2. Here we want to find the value of x and give our answer in simplest radical form. The hypotenuse is equal to the leg times square root of 2. The hypotenuse is given to us this time though, not a leg, so we plug 5 in for the hypotenuse, which is equal to x radical 2 because the leg is the length we're looking for. Divide by both sides by radical 2, and then rationalize. And remember, rationalizing, we multiply the top and the bottom by the radical in the bottom. And that gives us 5 radical 2 over 2 for x. A 30-60-90 triangle is another special right triangle. You can use an equilateral triangle to find a relationship between its side lengths. In a 30-60-90 triangle, the length of the hypotenuse is twice the shorter leg, and the length of the longer leg is the length of the shorter leg times radical 3. And you can see the picture in the bottom. AC, the red line, is S. AB, the hypotenuse, is blue, and it's 2S. And the green one is S radical 3. Here we want to find the values of x and y and give our answers in simplest radical form. The hypotenuse is twice the shorter leg. The hypotenuse is what's given to us because it's across from the 90-degree angle, so that's equal to 22, and we'll make x equal to the shorter leg. So 22 equals 2x. We divide both sides by 2 and find that x is 11. Remember, the long leg is equal to the short leg times radical 3. The short leg was 11. So this will be y equals x radical 3, and x was 11, so y is equal to 11 radical 3. Here's another 30-60-90 triangle where we want to find x and y, but this time the longer leg is given to us. The longer leg is equal to the short leg times radical 3. We plug in 15 for the longer leg, and now we have to divide both sides by radical 3 to get our answer. And remember, you need to rationalize by multiplying the top and bottom by radical 3. This gives us 5 radical 3. Initially we get 15 radical 3 over 3, but 15 over 3 reduces to 5. Now we know the hypotenuse is twice the shorter leg, so y is equal to 2x. We plug in 5 radical 3 for x and get that the y is equal to 2 times 5 radical 3, which is equal to 10 radical 3. So x is 5 radical 3 and y is 10 radical 3. Here's your lesson quiz. Make sure you practice these a lot because you'll be using them a lot next year in trigonometry as well as further on this year in trigonometry. And special right triangles are one of the most common things you use in trigonometry. If you don't know these, then you're really going to be lost on a lot of other subjects. So make sure you study them hard, memorize the rules, and practice them on your lesson quiz and then again tomorrow during class.